Hi guys, in this video we're going to talk about limits, and more specifically we're going to talk about piecewise functions and their limits. So this is a little formula, not a formula, but just a fact you got to memorize, and you will. It says the limit as x approaches some number c of f of x exists if and only if the limit as x approaches that number from the left of the function is equal to the limit as x approaches that same number from the right of that function. So this means the left-handed limit and the right-handed limit of a function at c has to be equal for the limit at c to exist. So I want to write that out real quick. The left So you could, that if and only if, you could read them both ways. It says the limit as x approaches c exists if the limit from the left equals the limit from the right. Or we could say if the limit from the left is equal to the limit from the right, then the double-sided limit exists. So it says checking the left-sided and right-sided limit is easy when given a graph, like we did last time. But it's not always as obvious when working with equations. So we could say for a continuous function, which we'll talk more about continuity and what it means to be continuous soon. For a continuous function, we do not need to worry about left and right-sided limits because we know they are approaching the same value. Okay, one common type of a function we will see throughout AP Calculus is the piecewise function, which is what we're going to focus in on today. So you might remember from your previous math classes what it means to be piecewise. Piecewise functions are functions built from pieces of different functions over different intervals. Because of this, they will appear throughout the course in a variety of ways. The laws of limits still apply. So we have three different piecewise functions. This one's going to be the f function, the g function, and the h function. And this piecewise means when x is less than 0, the graph would look like that, just be a straight line. If x is greater than or equal to 0, then it would look like x squared plus e to the x, which I'm not sure what that looks like. But it would look like something on the left and then something on the right as it approaches to 0. So one thing that we're going to look at and make this kind of tie into what we've done before is if x is less than 0, if I'm looking at 0, this is going to be from the left. When x is less than 0, that's what it's looking like from the left. Can't spell left. If x is greater than or equal to 0, we would say from the right. That's on the right side of 0, so from the right, that's what a graph looks like. Now at 0, this one would look like this bottom one, but at 0, it doesn't matter as much. This line could be under there. It wouldn't make any difference. But this g function, it looks like at 1, the graph is just 5. So on the left side of 1, the graph looks like some parabola opening downward. And then so it would be like an open circle. And then at 1, it's equal to 5. And then after 1, it looks like whatever 5x minus 2 would look like. So that's all the different pieces of that graph. But the top one would be from the left, and the bottom one would be from the right. All right, let's see how we kind of use that. So A says, what is the limit as x approaches 0 from the left of the f function? I should erase that. This is from the right. So if I want to find out this, I'm just going to plug in 0. If I want to look at what is the function, or what's the limit of the function as x approaches 0 from the left, I'm going to plug in 0 here. So 2 times 0 would be 0, and then 0 minus 3 would give you negative 3. And it's that simple. Part B says, okay, what's the limit of the f function as x approaches 0 from the right? So from the right, I would plug in 0 there. Now, it's actually defined to be 0 here. It's not defined to be 0 in the first one, but it didn't matter for part A, because the limit is saying what is the y value, or what are the y values getting really close to as the x's get closer and closer to that number. All right, so from the right, I'm going to plug in 0, so it'd be 0 squared plus e to the 0. 0 times 0 is 0. Anything to the power of 0 is 1. Well, not anything, but something, e to the power of 0 would be 1. So the answer there is just 1. All right, the limit of the f function as x approaches 0. So this is a double-sided limit. It's wanting to know what's the limit as x approaches 0 of f of x. Okay, well, if I look at these last two limits, if they're not equal to each other, if they're not approaching the same number, what does that mean? What does that tell us? Now remember, we just talked about this, right? The limit only exists if the limit from the left is equal to the limit from the right. And since those aren't equal, we're going to write D and E. Does not exist. All right, f of 0, which means what's the function value of f at 0? Well, the function is defined to be at 0 when x is 0 for the bottom one. So this, if I plugged in 0, I would get 1. Same thing I got from answer choice B, or problem B. All right, so for this next one, these are all questions about the g function. At any point, if you want to pause the video and try some on your own and then just restart it, don't forget you can do that. All right, so the limit of the g function, remember what function we're talking about, as x approaches 1. Well, I need to know what is the limit as x approaches 1 from the left of the g function. Okay, plug in. This would be from the left, right? That's when x is less than 1, that's from the left. So plug in 1 here. So it'd be 4 minus 1, which is 3. I also need to check the right-handed limit. So the limit as x approaches 1 from the right of the g function. This is from the right, so plug in 1. 1 times 5 minus 2 would be 3. So since they're the same, we can say the limit, the double-sided limit, would just be 3. All right, part F says g of 1. What is the g function evaluated at 1? It doesn't care about limits. It's just going to be 5. When x is 1, g is 5. All right, last two. The limit as x approaches negative 3 of h of x would be equal to what? So again, I need to do the left-sided and the right-sided, right? Okay, well, this looks different. This is what the function looks like if x is not negative 3. If x is negative 3, the function is defined to be 0. So, it's kind of weird. I need to plug in 3, negative 3. Well, if I plug in negative 3, see what we would get. Let's just kind of work with this. Okay, if I plug in negative 3 squared would be 9. 9 minus 9 is 0. Okay, plug in negative 3 on the bottom. That's 9 minus 21 plus 12. I've got 0 on top, so is the answer just 0? Well, if I look at the bottom, I also get 0. And that's something we'll talk about soon coming up also. This is called an indeterminate form. I get 0 over 0, so that's a problem. But if I think about it, my function is not actually defined right there. When x is negative 3, the function is going to be 0. So let's see what would happen if I factored the top. Factor the difference of squares would be x plus 3, x minus 3. Factor the bottom would be x plus X plus 4, x plus 3. So if you notice, the x plus 3 factors cancel. So that's what the problem was. If I plug in -3, that's what is my restriction. So that's gone, and I just get x minus 3 over x plus 4. Now if I plug in -3, we would get whatever -3 minus 3 is. So just plugging in -3 for the x's. I get -6 over 1. So the answer is just -6. All right, so the trick there was to have to factor, and we'll see what's going on there more later. But we factored it, and then we plugged in our number. All right, h of -3, function value when x is -3, that's just 0, that right there. All right, let's continue on. It says, let k of x be the piecewise defined function above where c is a constant. Find the value of c such that the limit as x approaches 2 of k of x exists. So find the value of c so that the limit exists as x approaches 2. So if I'm thinking about it, as x approaches 2, this is from the right. I wonder if that would help us at all. And then this would be from the left. And then anything below 0 is looking like this. So it's all about where the limit as x approaches 2. So really, I don't need that extra part up there. That's just extra kind of there to throw me off. It's all about what's happening at 2. What's happening just to the left of 2? What's happening just to the right of 2? And what I need is the c value that would make that limit exists. And the limit exists if the left-handed limit equals the right-handed limit. So if the function value on the left is equal to the function value on the right. And I will look at that and think, okay, I got to solve this for c, but I've got c's and x's. We're trying to find c, so what should we plug in for x? We're going to plug in the 2. So it'd be 7 minus 2c. Because that's what we did earlier, right? The function value that I'm plugging in when x is 2, we did that all up here. Like if I want to find the limit when x was -3, we plugged in -3. If I want to find the limit when x was equal to or approaching 1, we plugged in 1. So I'd plug in 2 here. So 2 plus 1 would be 3. 3 squared is 9 minus 5. And then from here, it's just a simple little equation that I'll probably mess up. 4 minus -3. So was that c equals 3 over 2? And that would be our answer. So also I'm going to close this video because the last part of this is just a separate little scenario with this left-handed, right-handed limits. I'm going to pause here just so that the video doesn't mess up.